Hey, hello everyone. Welcome back to the Amazon EKS series. This is Saina. So let's have a short recap of what we have done till now. So we have started an Amazon EKS series, and this series is completely open for beginners. And till now we have covered uh, until now, we have understood what is EKS, how to access your EKS cluster. We have also looked into the Amazon EKS, AWS Client VPN, how to integrate your client VPN with your VPC and access the access the resources which are inside your private subnets securely from your local system. So this is the part 2 of our previous video. So in previous video we looked into the complete manual setup. We were going inside the console and clicking everything to set up the infrastructure, but in this video we will do complete automation using Terraform. So I highly recommend you to watch these two videos first, because those are the prerequisites of this video. In this video, I explained what is client VPN, how to set up client VPN and everything. And in this video, I have explained that how to integrate that with your VPC and access the resources which are inside your private VPN, private subnet from your local system, which was complete manual setup. And now in this video, we are doing the same setup but via Terraform. So I highly recommend you to watch these two videos because they are great prerequisites, and also you should be having a basic understanding of Terraform. So this is the complete GitHub repository. The all codes will be present in this video repository, so you can follow these repositories for your reference. So a short overview before we move on to the hands-on part. So we have our AWS cloud. Inside that cloud, we have our specific AWS regions like AP South one, US East one, or any other region of your preference. And then inside that, we will run a VPC, and this is the CIDR range of our VPC. And inside of that VPC, across the availability zones, we will run our workloads. Like inside this example, we have AZA and AZB as our availability zones, and inside each availability zones we have our public subnet and private subnet in both the availability zones. And then we will run our control plane and workloads node groups inside the private subnets of both the AZs. Why inside the private subnets? Because we want to make our EKS cluster complete private, and only the specific users should access that cluster. And then we have our AWS client VPN, and this is the CID range of client VPN. And then when we are setting up client VPN, we follow the three aspects, which are those: network association, authorization rules, and security group. All these three things I have explained in my previous video. Do check that out there. So by network association, we are associating these subnets. By authorization rule, we are only giving access to them specific subnets. And security group, we are allowing request from VPN to be accepted to our control plane. And these are the clients from their local system. They will be connected to the VPS client, and from there they will be accessing the resources from our VPS. That's the complete architecture over here. And now we will straight move towards the Terraform, where we will be completely automating these all things. So now from here we will start our hands-on part. So make sure you have your Terraform installed in your local system. And now what I will do is I'll copy paste the each code block from my repository to here, and then I'll explain those each block one by one for you. Because if I try to write all the codes one by one, it will take a long time for you to write and understand. So I'll simply explain one by one each block. And while writing the code, we will make sure that we are following the best practices. We will try to write the modular code and try to reuse the code as much as possible. So firstly, we will create a modules folder, and inside this modules folder, like in our architecture, firstly we want our VPC. Inside that VPC only all our infrastructure will come, right? So we will firstly create a VPC. So vpc.tf. So firstly, we have the VPC resource block. So by this resource block, we are creating a VPC. And this is the CID range. We are taking the CID range from the variables file. And what's that CID range is? uh, 10.0.0.0/16. This is the CID range for our VPC, and the instance tenants as default, enable DNS host name and enable DNS support as true. And these are the two tags that we are giving to our VPC. One is name and another is env. And the value for these are coming from the variable files, which we will create later. And next, we will be creating an IJW. So here we are creating an internet gateway, which is IJW. So this is the resource block for that. Firstly, we will provide the VPC ID. So we are following the interpolation. These are the best practices that what I have told. AWS VPC.vpc.id. So by this resource block, we will get a VPC ID and following the tags and depends on. So by depends on means this IJW is depending on this VPC. Means before creating IGW, we want our VPC to be created. That's what this means. And this tag, you may be having this doubt what this tag is. So by this tag, whenever our EKS wants to access this IGW, it can easily understand that this IGW is in present in that VPC and can be easily accessed. So this is the main use of this tag, and this is recommended to add this tag as well. And next we will create a subnet, specifically talking public subnet. So we have two subnets as I told in our architecture diagram. So we will be using a count variable from where we will be taking this number of public subnets you want. Like in our example, we are saying we want two public subnets, and then VPC ID against interpolation and CID are block. We will be passing the one list array list of CID ranges, like like this. Mm, uh, like the CID range, we will be passing from variables file. And then same for availability zones as well. We are using the counts variable, by which we are using this element attribute and passing var.availability zone.count.index. And then map public IP on launch instance. We will do that as true because we want public IP address to be available for public subnet. And then tags and depends on, because public subnet only be created after the VPC is created. So next we are creating a private subnet. So this is the private subnet. Again, the concept is same. Just we are telling we want two private subnets by this count variable, VPC ID, CIDR block. Again, passing from the variables file, availability zones. Again, passing from the variables file. Map public IP on launch will be false because we don't want any public IP to be available there. And then tags, and then depends on section. And next, now we will be creating a route table. So here we are creating a route table for our public subnet. So this is the resource block for that. We are giving the VPC ID and route CIDR block we are giving as 0.0.0, and gateway ID should be AWS Internet Gateway ID. Like when we say a subnet is public, only when we have we that only when that subnet has access to the IJW internet gateway, then only that public subnet will become a public subnet. So that is where we are giving this CID range. Anyone from the outside can access this IJW. And then tags, and then depends on section. The same way now we will be now we are creating a public route table association, because we want our route table to be associated with our public subnets. So this is that block for that. So the count we are giving public subnet count, because we have two different public subnets, and we want those two public subnets to be associated with our route table. So the count and subnet ID of our subnet IDs of our VPCs, like public subnets, and then route table ID. So by this, again following the interpolation method and depends on section. Now here we are creating the NAT gateway. So why NAT gateway is needed? Because our workloads are inside the private subnets. So whenever our EKS cluster wants to connect to the internet, there needs to be a way to have that connection. So for that reason, we are connecting this NAT gateway. So now here we are creating the NAT gateway. So this is the resource block for the Elastic IP and NAT gateway. So here we are creating a two Elastic IP giving count again from variable file, domain is VPC and a tag name and depends on section. And here we are creating a NAT gateway, and this NAT gateway are specifically present in a public subnet. So the count variable, we want two NAT gateways to be present, one in each public subnet zone, and then allocation ID. Allocation ID will be coming from this Elastic IP ID, and subnet ID is a public subnet ID. And then finally, here we are creating a private route table and private route table association. We created public route tables so that they can associate with public subnets. Now here we are creating a private route table and association so that they can be associated with the private subnets. So this is the block to create a private route table. So VPC ID, again we need a count variable because we need two VPC route tables, one for specific subnet, one for specific private subnets. So this is the CIDR range. CIDR block is 000 and NAT gateway. So the request can be only accessed by this NAT gateway. And then a tag and depends on section. And here we are doing association of that NAT gateway, sorry, of that route table, private route table with the private subnet. And all this components are done. Now by this, your VPC will be created. Everything like public subnet, private subnet, Elastic IP, internet gateway, association, everything is done from this block of code. And now next we will be creating an EKS. So let's make a file for that also, eks.tf. But before EKS, while I was explaining in my first video, we need uh, some specific rules to be created for our control plane and node groups. So we need those rules and control. Sorry, we need that rules and policies to be created first, so that we can attach those to this EKS cluster. So before creating EKS cluster, let's create a those rules and policies. So let's create this one file im.tf. So inside this we will create that all rules and policies. So now let's start our im thing. So firstly we are using this random integer block. So why we need this? So that we can add a suffix to all our rule names and policy at the end of our rule name. And next we will create an, so now we are creating an EKS policy, sorry, Amazon EKS cluster role for our EKS. So this is the name that we are giving to that role, and this is that suffix that I was telling. Means a random integer in this range will be added to this role, and this is the assume role policy that we are giving. So assume role allow as service eks.amazon.com, and next we need to attach a policy to this role. So by this, we are attaching a policy to this role. So which role? AWS IAM role.eks role cluster. So this is referring to this role, AWS IAM role, AWS IAM role dot EKS cluster role dot EKS cluster role and name. So this role, we are attaching this policy. This policy is managed by AWS. So by this, our EKS cluster policy is created. And next, we are creating uh, this one. We are creating EKS node group role, because here we created a role for our control plane, and here we are creating a role for our node groups, and this is the name for that node group. And assume policy as ec2.amazon.aws.com. And for this role we are attaching these three policies. Which all these three policies? Amazon EKS worker node policy, Amazon EC2 container registry read only policy, and EKS CNI policy. So these three policy we are attaching to this role. And lastly, we are creating the security group. Why we need the security group? Because we want our EKS to accept the request only from the client VPN. So for that reason, we are creating this AWS security group. So this is the name for our security group and VPC ID. In this VPC ID, tag names and ingress, we are giving the from port as 443, to port as 443, and from where the request to be accepted from this where.client CIDR block. Where.client CIDR block is which one? That will be our 192.0.0.0/16. Any request coming from this will be accepted, and the egress rule. And yeah, now our IAM things are done. Now we will straightly head towards creating an EKS. So come to your EKS.tf. So firstly, we will create a control plane. So to create a control plane, so this is the resource block. So we are giving a name. This name will be coming from our variables file, and role ARN that just be created in our IAM thing, AWS IAM role dot EKS cluster role dot ARN, and version that we want to use for our EKS, and Bootstrap public managed add-ons. So by true, you are seeing that all the add-ons that are required to run this EKS cluster will be installed by default. If you make it true, or if you want to add any other specific add-ons, you can add them also. And then in VPC config block, we are giving the subnet IDs. Means we want our control plane to be running in only in private subnets. So those subnet IDs we are passing here. AWS subnet ID dot private subnet ID 0 means we have two subnet ID. So 0 and 1. And endpoint private access. If you want to make this control plane private and public. So for private, we will be passing a boolean value true and false here. So here we will be passing true, and for public we will be passing a false. And security group IDs. So we created the security group ID here in our IAM. This one, this security group, we are passing there here for our EKS control plane. And then access config, authentication mode as API, yeah. And then Bootstrap public cluster administrative permission is true, because we want the one who creates this EKS cluster to have a administrative permission. And then we are giving the tags. So now here we are creating a node group. So this is the resource block for that. So again, cluster name and node group name, node group role ARN, subnet IDs. Again, we want them to be created in a private subnet only. So we are passing those IDs, and instance type and capacity type. Instance type is like T2 medium, T3 medium, or T3 large, which type of instance you want, and capacity type. So basically, we have two types of capacity, like on demand and spot instance. So basically, on demand are cheaper ones, and spot instance are quite heavy costlier. So next we are passing a scaling config, like desired size, min size, and max size. So I have explained these all things in our manual setup. Well, I assume that you all know these things, like desired size, maximum size, and minimum size. And next we have update config. Max unavailable is 1. So by this 1, what do we say is that whenever we are updating our EKS cluster, how many nodes we want to be unavailable? That is 1. And disk size is 1, and then we are giving some tags and depends on section. So by this, your both control plane and node group is created. So now let's create a vpn.tf. So now, like I have explained in my previous videos, before creating a VPN we need our certificates, so that they can help us to set up that mutual authentication in our VPN setup. So firstly, we need to create those certificates: CA authority, certificate authority, and then server certificate, and then client certificate, and corresponding keys. So here we are firstly creating a certificate authority. So this is the resource block for that. We are using a TLS provider for this to create. And if you don't understand this how to create the certificates, you need not to worry about this, because whenever you are working in organizations, you will get this all certificates already created. So just follow with me. If you don't understand this certificate things and all, Don't worry. So here we are using algorithm as RSA and creating a certificate authority. And next we are creating a certificate authority. And here we are creating a certificate for that using that key. Subject we are passing here common name and organization. Validity we are giving it as in hours. It's basically 10 years. Again we are deleting all these resources once we perform this demo. And next allowed users. So here we created a certificate authority, and next we will create a server certificate. So here we are creating a server certificate. So here we are creating again a server key firstly, and then CSR, so that we can sign that we can create a certificate using that CSR with that server key. Here we created that server CSR. CSR stands for certificate signing request. So firstly we create a request and then we sign that request to create a certificate. That's the basic flow of that. So again, if you don't understand that, you need not to know much about these things. And then we are passing all those things, required things, allowed users and set subject key ID as true. Yeah. And here we created a server certificate and key. And next we will create a client certificate and key. So again the same thing, creating a client key, creating client CSR, and creating client certificate. So by this, all your uh, certificate authority, client certificate, and server certificates, all three are created. And nextly, we will be importing your server certificates and certificate authority to your ACM. ACM stands for Amazon Certificate Manager. So we will be importing these things to our ACM so that whenever we are creating a VPN, we can access those certificates from there. So from here, we are importing certificates to ACM. Which certificate? Firstly, we are importing a server certificate. So the private key, certificate body, and certificate chain. So these three things are required to create a certificate in ACM. So that is what we are taking it here and importing that to your ACM. Same thing for certificate authority also. So both your server certificate and certificate authority are imported to your ACM. And now we will create a VPN client. So from here we are creating a client VPN. So this is the block to that AWS EC2 client VPN endpoints block name as VPN. So we are giving a description. Server certificate ARN. We are taking it from ACM and client certificate CIDR block. Here we are passing CIDR block as again passing it from the variables file as 192.0.0.0/16. So this is the CIDR block of our client VPN and the VPC ID, in which VPC ID will be that present, and split tunnel as true. Again, I have explained that this is very much important to make it as true, or if you or else you will not provide this. What happens is any request that you are doing in your browser will be going via this VPN. If you don't do that true, if you do that true, only AWS specific request will be going via this VPN. And then authentication option as a certificate authentication, because we are using certificates to do that mutual authentication. And next connection log options, we need to make this enable as true, because all the things like who which user tried to access our VPN, which user accessed, everything will be present in our logs. We can access that logs and see all the logs in our CloudWatch. And then session timeout hours, make it as 8, because we want our VPN to be terminated for every 8 hours. And then a banner, client login banner means whenever you will be connecting to your VPN, you will get this message. This VPN is for authorized users only. So when I will show you this when we will be connecting to your VPN. And next, we are associating our VPN with the subnets and creating authorization rules. So here we are associating that. we are seeing a client VPN endpoint ID. So VPN endpoint ID should be associated with this subnet, private subnet. You can associate with multiple subnets as well, but in this demo we are associating it with just only one subnet, one private subnet. And here we are creating a authorization rule. And in this authorization rule, we are saying that only requests should be going to the private subnets. Target network CIDR, var.private subnet CIDRs. See here, we are giving request only to the private subnet CIDRs. And authorize all groups equal to true means who has access to this client can access this subnets. And next, here we are creating that CloudWatch logs. We need to create a log group in our CloudWatch so that all the logs will be written in this folder AWS VPN at this name and the retention key and the CloudWatch log stream. And here we are creating an output block so that we get a client certificate and client key so that we can use these two things to connect to your VPN. And yeah, now your VPN is also set up. Complete VPN is done. And now next we are getting all these red errors, right? Because we not created a variables file. Now we will create a variables file here. So now I have copied all those variables file here. So see, now all those errors are gone. So we have cluster name as variable. Again, we will be passing this variables file from our .tf var files to these variables, and then it will be taking it in these all files like in this EKS wherever we are using all those things like cluster name, VPC CIDR, ENV name, and then IJW, public subnet count, everything we will be passing it from our TF files. So yeah, now our modules thing is done. Next, we'll create another folder, EKS, and inside this, we'll be creating a multiple files. Like firstly, we will be creating a backends.tf. TF. So we need a backends.tf. And now inside this we can give all our providers information like here Terraform required providers as AWS. So we are using this version of our AWS provider and using backends as S3. So give the backend name. You need to create this bucket in your S3 by this name so that why we need this backend.s3 because we don't want our code to be updated by multiple users at the same time. And that's why we create this S3 bucket, and by which we get a this use log file as true. Means whenever one user is trying to create or update our Terraform files, multiple other users will get errors whenever they are trying to access our update our Terraform code. So by this block that is done, and then provider region at which region we want this to be created. Again we are passing this from variables file, and here we need to again also created a one more file as variables.tf, and we'll copy this variables file from here to here also because we need that. And we also need to add one more variable over here. uh, Variables AWS score region. So this is that another region we have, and value to these all variables we will be passing from tf var file. So we need to create the tf var file also. So test.tf vars dot yeah test.tf var files, and from here we will be passing all the values to here. And also we need to create a main.tf. From here only our modules location will be given to all these files. So this is our main.tf file. So here we are creating a locals block, giving an env variable and organization name. Organization means give any dummy name over here, and then we are creating a module block and form and giving EKS as name to that module, and giving the source means we are telling to look to all these files at this location, at this module's location, and inside that we will be passing all the values like whichever we want. Env we will be taking it from this location, and then cluster name we are creating cluster name as this at the rate local.env, and then not at the rate, like in like this is the formatted one, local.env. This env value will be coming from here, again from var.file, and local.org is yt. Var.cluster name again will be coming from tfvar files. Same for all the things: cid or vpc name, ijw name, public subnet count, private subnet count, cid or ranges, everything, NAT gateway name, cluster version, and then private access, and then desired size, min size, max size, and then VPN domain name, everything. And then here we also have this output block. And next, we'll update our TFR files. So here are all those values that we are passing. Like here, AWS region, we are choosing that as this. ENV as dev, cluster name as EKS demo, and then VPC CIDR is this. Here we are passing those ranges, and then VPC name as this, IJW name, IJW subnet count, public subnet CID range. So 10.0.1.024 and 2.0/24 as public subnet CIDR, and public subnet name as this, and the private subnet count, private subnet CID range, private subnet name, availability zones. We have two availability zones, and then private routable name, public routable name, elastic IP name, elastic gateway name, cluster version, private access as true, public access as false, instance type as T3 medium, capacity type as on demand, and then desired size, max size, and minimum size, VPN domain name, and client CIDR block. All the values passing it from here. Why we do this? Because if we need to make changes anything, we can directly do it changes over here, so that we need not to go the specific file and make changes it here, because we have completely variabilized and trying to make much use of reusable codes, right? So that we are using this .tf files, so that if you want to make any changes, we can straightforward come to this file and can apply those changes here, and these changes will be directly applied to your infrastructure. And yeah, now our complete code setup is done. Now we will look into the straightly we will apply these all things. Now what we will do is terraform init. So use this command so that terraform is initialized. So come to this firstly to the EKS folder. So inside cd EKS, so inside this terraform init. So all the providers backend TLS provider will be, so okay, so I don't have this bucket name. Oh, I have some other bucket name. Let me change that. So yeah, now I've changed that, and now we will apply it once again. So it has successfully started initializing provider plugins and all those things. So let's wait until it get initialized. So now our terraform init command has been succeeded. Now let's plan our infrastructure. Terraform plan. So we are using .tf farewell where file as test.tf where, and then hit. So this command will plan your entire infrastructure first. So we are getting some error locals in vpc.tf. Oh, I think we have not declared a local block here. Oh yeah, really. So we need to do that. So so in vpc.tf, give this locals block and then try once again. So yes, now the plan has been succeeded and it is telling 43 resources to be added and 0 to change and 0 to destroy. So now let's hit apply button. Apply. So now it will nearly take 15 to 20 minutes to set up your complete infrastructure. So it will ask for yes, it is. So what I will do is I will pause this video and I'll come after once this infrastructure is completely set up. So yeah, now our infrastructure has been set up. Resources 43 has been added. So let's look into our console. So this is our VPC that we got created, and this is the cluster. And let's see for client VPN, client VPN endpoints, and here is that client VPN. See here, network association has been done. Authorization rules have been added. Two authorization rules for these two subnets. Everything has been done, and now let's access this. To access this, you need to download this client configuration. So download this client configuration first. So yeah, a client configuration has been added, downloaded, and now you need to add client key and client certificate in that configuration. Now how you will get that client key and client configuration? So to get that, so for that you need to use these commands to create a client certificate. So see a client certificate file will be created. So let's wait until this command has been succeeded. So see, a client certificate has been created. The same way we will create another file which is this. Don't worry, I will provide these commands in the GitHub repository. So client output hyphen raw client key. So client key also is now created. And now we will use this both credentials in that configuration file. And now to access that, you make sure you have installed AWS Client VPN in your local. So let me open that AWS Client VPN. So this one. So I have this one Terraform. Let me delete that. So firstly we will update that. So I'll go to my this one downloads, open with notepad. So this is that file, and here we need to add those credentials. One is cert. So so client cert, I will copy this, come here, paste it. Same way I will do for key also. And I will copy the key content here. Paste. So yes, and then save this, remove this, and now to here VPN, come to file, manage profile, add profile, give any name, and then choose that configuration file. So this is that file, open, and once opened add a profile, and then done, and then hit this connect button. And this is now your local is trying to connect to that VPN. So wait until it get connected, and it got connected and you got that message. This VPN is for authorized users only, and hit this OK button. And now from here, in this local, you can easily access your Kubernetes resources. So but before that you need to update your .config kube file. So for that we have command also. So I have that command in the first part one only. So this is that command. I will use this command. I'll paste that command here. I'll change the region AP South 1, and name of our EKS as, what's our name of EKS? YT So this is the EKS name. So hit enter, and by this updated context, a kubeconfig file has been created. And now let's access kubectl get pods, rather get nodes. And now so I'm getting this error, and hope you will be also getting this error. I think I have missed something with the security group. So but now what we will do it, we'll do it manually. So what you will do is come to your this cluster, and in this networking tab go to your security group, and in that security group you need to allow this one. In details tab, come to client VPN, in details tab take this security group ID, and that edit inbound rule, add a rule for port 443 to this one, and then save rule. I think this is the issue that we are facing. Let's try this and see. and then come to your this one terminal again, and again try to hit that kubectl get pods get nodes. Yeah, now we are getting the response. Yeah, that was the issue that we were facing. I think we have messed something in the code here and there. I'll check that and I'll update that in the GitHub repository. Don't worry. But that's how you do. If you give the exact command, exact security group ID, your request should be routed. See, we got here successful request like kubectl get nodes, kubectl get ns. Yeah, he can do anything because the user that has been configured here is that administrative user and he has complete access to the infrastructure. And now the same way you can add multiple users like I have told in my previous videos how to create multiple users, access group, access entries, and you can add those entries over here and you can play with this Kubernetes cluster as you want. And yeah, that's how you implement your complete infrastructure with Terraform. And now if it comes to destroy this Terraform, what we will do is firstly we will remove this security group ID because we added this manually, right? We don't want to get any unknown errors in our infrastructure. So let's first delete this. Delete, save rule. So yeah, and then come back to your this one and here let's delete terraform destroy hyphen var file is equal to test.tf vars. Oh, test.tf vars. Yes, and hit enter. Oh, destroy typo destroy, yes, and then hit enter. And so it will ask for confirmation. Hit yes, and again it will take 15 to 20 minutes to destroy your entire infrastructure. And that's how your automation is been done. With just one click, your complete infrastructure has been implemented, and just with one click, your complete infrastructure has been deleted. That's the use of Terraform, and that's how complete automation is done. And yeah, your part two now successful. In next video, we will look into the security concepts as in we'll look into the IRSA, power identity, RBAC, all those things. Like, but in our like three videos, we have only looked into how to access the cluster, but we never the user specific permissions like using RBAC, fine grained security principles. So in next video, we will look into that and how to give the multiple users specific permission and give access to access for accessing clusters. And yes guys, that's it for this video. Hope you like this video and enjoyed this video, and make sure to like and subscribe to my channel, and wait for more such content. Till then, bye bye.